Hello, viewers. Today we are going to start our new topic, that is risk and uncertainty in decision making. We did our linear programming and we looked at how we can be able to make a decision using the linear programming. So what we are going to go through today is we want to look at some of the things that some of the techniques that we are going to implement here when we are making decisions under risks and uncertainties. So let's try to look at the uncertainty, because we are going to get an introductory part where we are going to be talking about the definition of risk, definition of uncertainty. We look at the decision making under risks, where we are going to look at something called the expected values or the expected payoff or the expected monetary value, EMV. We are going also to look at the terms that are used under decision making under risk. Then we also look at the other technique that we can use to make a decision, that is the decision tree. So we are just going to have an introductory part where we are going to be talking about those things in details. So for those who haven't subscribed, please subscribe to the channel, because we're going to be able to have this information that can help us improve our understanding, and it will also help the channel to grow, because whoever subscribes, it's a sign of appreciation for the kind of work that we do for them. So without wasting more time, let's try to look at what a risk is. So we've said that even under risks and uncertainty, we are going to make decisions. But the decisions we are going to make, they are based on risks and uncertainties. And sometimes the examiner asks for the steps in decision making. Most of the times when they ask that part, you find that it's going to be asked under this risk and uncertainty. So we are saying that risk involves situations or events which may or may not occur, but whose probability of occurrence can be computed mathematically. And the frequency of their occurrence can be predicted from the frequency of their occurrence is predicted from the past event or the past records. But when you look at the side of the uncertainties, you find that uncertainties means events whose outcomes cannot be predicted with statistical confidence or mathematical confidence. In other words, even the probabilities, we can't ascertain the probabilities. Most people think that these two terminologies, they are the same, or they mean the same thing. That analogy is actually wrong, because when you're talking about risk and uncertainty, those are two different items. They are completely different. And their application is also completely different. when we talk about the risks, it's mainly used under the sports betting and other gambling activities. Most of the times, that's where we find the application of the risks in those betting and other gambling companies. Because those companies, for them, their activities, they base on chances. In other words, the chances are based on the past records. For example, you may look at sports betting. These people who are dealing in, these companies that are dealing in betting, gambling activities like betting and all that, you find that if there is a match, if let's say we can just assume the match that concluded recently, that was Arsenal and Manchester City, the Community Shield, you find that one person can look at the two teams and check how they have been performing in their past. You may find that they may say that maybe Arsenal has been performing better, or it is Manchester that has been performing better. But they are comparing their previous matches or the previous performance. In other words, we are checking the past records of those two companies, of those two clubs. And you may find that someone can say, me, I'm betting that Manchester is going to beat Arsenal, or it's Manchester that is going to win the match. So you find that someone is basing on what was happening previously, or what happened in the previous matches that they had, to benchmark what will happen in the match that they are going to bet on. You may find that maybe Arsenal has been losing and the other team has been winning. So someone can just base on those past or the previous performances that were there, so that they can be able to make a decision. Because even when you check you check on the internet, you find that there are those companies that are going to give you predictions of how they expect the match to end. They give you percentages that Arsenal has maybe 40% chance of winning, and let's say Manchester has 60% chances of winning. So you find that someone is just going to use those percentages. In other words, those percentages, they are the ones we call probability, or the chances of a given team to win. Because if you find that both the teams, they have been performing good, they had a good performance in the previous records, you can say that we are going to be having a 50-50 chances, this one winning and the other side winning. So you find that someone is going to bet according to what has been happening the previous months, even if it will not give you the exact result. But here you have a basis for you to make a decision on which team you want to bet to be the one that is going to win the game. So we base on those past events and the probabilities that we've gotten from the facts that we've collected, and we make sure that we make the decision according to the way we see things, but we have based on the previous performance. But when it comes to uncertainties, you totally have no idea about the outcomes. For example, if let's say Arsenal and Manchester City, they had never met before, they have never played anywhere, you don't have any past record to benchmark your performance or what you assume may happen. In other words, it is their first time of meeting. Then you find yourself you can't even access any information about the previous performances that they had, so that you can use those one to benchmark. Here we have no idea about what the outcome may be, because we can't get any information that can help us benchmark. So here you can just decide to bet on any team. You can say Arsenal is going to win or Manchester is going to win. If at all you don't have any previous records that you can use to benchmark your decision. In other words, here we don't have percentages. We don't even have past records. We are just making decisions basing on how we see things, and we just wait for whatever comes out. Because if it is their first match and they have never met before, there is no way you are going to make the comparison so that you can make an informed decision. So if that happens, then it means we are under uncertainty, because we don't have any percentages or we don't have any probabilities that we can use, and we don't actually have the past records. For example, if let's say existence of floods, you may find that the area is very flat, yet you find that there is an occurrence of, let's say, floods or landslides. In that thing has never happened, but you see certain thing happening, and you start wondering, because there is no way you had not provided for that, you had not catered for it, because it had never happened before. But if you be in a place where you see that every time, maybe during the rainy season, you experience the landslides and flooding of the surfaces, you find that you can now benchmark. Maybe you can that one for that you have the past records. You've been experiencing that in every rainy season, so you be expecting it. So you can also make decision and say, in the next coming wet season, we may experience floods or landslides, depending on what has been happening in the previous periods. In other words, from there, you will be having the past records that you are going to use to benchmark, so that you can make a prediction of what may happen in the future. And that's what we do under risk. But for uncertainties, if the topography of the land, you find that the topography is flat, but you find yourself experiencing landslides, floods, then when those things have never happened and you had no idea where they came from, you can't even predict when the next one is going to happen. If you don't have any idea of what may cause even what you are seeing, then we can use that and we benchmark. We can say that there, whatever comes is what we go with, because it's in periods of uncertainty. So there is a very big difference between risk and uncertainty. So we need to look at risks and see how we are going to be making the decisions. And you also need to look at the uncertainties and see how we are going to be making decisions in those perspectives. Where we've said the main key points here under risks, we must be having past records. In other words, we have the previous performances that we can use to benchmark. Secondly, we have probabilities, or we know that at least, just like the wise said, that during the wet season, we always experience flooding or landslides. You find that at least that one you can estimate and say, you can even forecast and say in the next coming wet season, we may experience landslides because it has been happening. You can say it is 90% we may experience it because it has been happening several times. Meaning you can even quantify. In other words, you can put a percentage that for this and this magnitude because we've been experiencing it. In other words, if it happens, you will not feel like you will not have any doubt because you've been experiencing that before. But for uncertainties, we find that we've never experienced what happened and we just see ourselves certain things happening when you have no idea how they came about. So we want to look at, if at all we're under uncertainties, how are we going to be able to make decisions? If at all we are under risks, how are we going to be making decisions? So we are going to look at the methods that we can use that can help us to know to know how we can arrive at the result that will help us to make a decision in any way. Because we've said under the risks, the results or the outcomes can be computed mathematically or with mathematical confidence. In other words, if statistically we can benchmark on what has been happening, then we can also use these methods that we are going to talk about to arrive at the result. But for the decision making under uncertainties, we are saying that under uncertainties, we don't have statistical confidence or mathematical confidence to benchmark our results or to find the results that we can do. In other words, there is no way we can confidently say in such and such periods we are going to experience this because it has never happened and you have no probabilities or chances that you can use so that you can be able to benchmark. So let's try to look at the decision making under risks. We've started with the risks. Then the other item that we shall look at later is decision making under uncertainties. So what are some of the methods that we are going to use that will help us to make decisions under risks? One, we have the expected value. We say the expected value is the same as the expected payoff, is the same as the expected monetary value. So what is this? This involves getting the expected values using probabilities given. In other words, these are the mathematical way we compute the results that we want. But how are we going to be making the decision? We are making a decision on the point that we pick that alternative that has the highest expected value, and it will be that alternative that we will choose. So how do we compute the expected value? We compute it using the formula below. We have the payoff of the state of nature. In other words, the state in the question, when you try to look at the question, they are going to be giving you the states of nature for the different products or for the different alternatives. We are going to be seeing the terms that we use under the decision making under risk. So when you look at the alternatives that we have, we pick the one that has the highest expected value. In other words, the expected value, it's what we were doing under our quantitative techniques. The expected mean. We get the probability, we multiply by the figure they have given to us. In other words, Here we are getting the payoff for the state of nature 1 times the probability of the state of nature 1. We add the payoff state of nature 2, we multiply by probability state of nature 2. In other words, we are just getting the outcome. This payoff is the outcome, what comes out of that alternative. The outcome we multiply by the probability. When we do that, we add for the different periods that we may have, because they may give you these outcomes maybe for 5 years. So we need to compute the probability. They will give you the outcomes for the 5 years, and they also give you their respective probabilities or the chances of that outcome to happen. So you just get the outcome, you multiply by its corresponding probability, you add, you keep multiplying those ones and you sum them up. That's what we call the expected value or the expected monetary value. We say this probability of the state of nature for the different periods. The state of nature is always going to be given to us. Let's first look at the terms that we have under the decision, under risks that we have, the terms that we have. We have alternatives. What are these alternatives? The alternatives, these are the outcomes that are within the control of the decision maker. In other words, these are outcomes that are within the control of, let's say, the organization. If, let's say, you are going to start a business, it's either you are going to start up a business or you are not. In other words, if you starting up a business that can be controlled, or it is within the control of the decision maker, you can either start a business or you decide not to start a business. You may decide to go to school or you may not decide to go to school. That is within your control. In other words, you can decide to move from one place to another, and you can also decide not to move. Because if you don't move, then we expect that you are not going to spend any money. So these are the things that are within the control of the decision maker. The decision maker is that person who is making a decision. In other words, if you just take it in the business perspective, in that someone or the sole proprietor may decide to set up the business, and at the same time, that sole proprietor has the control and power to say that I'm stopping this business. It's not like the way how you perform these other companies, because for the companies, you find that for you may decide to close the business, but the legal perspective may not allow you to close the business. But if it is on the side of the sole proprietor, we can see it is within the control of that person. You can decide to make a business or you decide not to. Then the other term that we have to know is the state of nature. The state of nature, we say these are the outcomes that are outside the control of the decision maker. In other words, if you start up a business, you have to understand that in a business or in a business environment or in a trade environment, we always have trade cycles where we are going to be having the boom, where we are going to be having the recession periods. You find that the business is going to be making profits, and at the same time, you find that the business is not going to be making profits. It's not that you are just, when you start a business, you are just going to be making profits throughout. If you start a business, you are not going to assume that all sales are going to be coming in every day or on every month. If you are talking about the weather, there is no way, if you start a business in a given community, there is no way you are going to influence the weather that is going to, if it is going to rain, there is no way you can stop it. If it is a dry season, that's how it is. Those are the things that we can't control as we who are making the decisions. If it is the competitor's price, there is no way you can influence the competitor's price, because for them they determine according to what they have incurred in the production process. You are not there. You can't determine the inflation rate. If the inflation rate is going to go up, you don't have any control about it. What you can only do is to see how you can limit its negative effects to the organization. So the state of nature is always the outcomes that are going to come in that are outside the control of the organization. In other words, when you try to look at the business environment, we always have the insider, the inside part of the company. Those are the things that we can control. That is the internal environment. That one we have control about it. But we don't have control of the external environment. In other words, we don't have control over customers. We don't have control over the other participants that are going to be outside the organization. So the state of nature will always be the things that we have no control, or the decision maker has no control about. Then we look at the payoff. We've been using the expected payoff, or we get the payoff of a given period, we multiply by the probability of a given period. The payoff is the outcome of the decision taken. In other words, if you start a business that you've made a decision to start a business, if that happens, what are you expecting to get from that business? We either expect to get profits, or actually we set business to make profits. These losses, they just come in, but ours, we always set that to make profits. So if you start that business, you look at making profits. And those profits, they are the ones that we are going to call payoffs, because that's the reward from the alternative you have taken. In other words, that will show your efforts in the alternative. In other words, what you aimed to make a decision to be in that alternative that you've selected. If you had different alternatives, maybe you wanted to buy land, you wanted to set up a company, you wanted to go to school, and you find yourself deciding maybe to go to school and you ignore the other alternatives, it means you have made a choice, or you have made a decision you have selected to go to school. If that happens, then we want to see the returns after you have decided to go to school. If you pass well and maybe you get what you wanted, you can, at the end of the day, do the other business that you wanted to do. So the expected outcomes of the decision that we've taken, in other words, the reward for the efforts of the decision maker, and these, they are always measured in monetary terms. In other words, if we can't quantify them, then they are not rewards. So that's what we can talk about as far as the terms that are used are concerned. So we've seen only one method that we can use, that is the expected value that we can use to make decision under the under risks. But we said we take that alternative that has the highest expected value. So when we compute the expected value, we select that alternative that has the highest. If you have project 1, project 2, project 3, and you find that when you compute their expected values, when you get the payoff or the reward, you multiply by the probability, you find their expected values. So you pick the one that has the highest. It is the one that we go with. So that is the first method. The second method that we use is, we said, it is the decision tree. here we had a simulation, but we are not going to do any practical simulation here. We are going to do them in our part B, or in our part 2 of this video, where we are going to be talking about the computations alone. But let's handle the theoretical aspect so that we can finalize it. The other one, we've said it is the decision tree. Most of the exam questions, they are going to be about this decision tree, because for it gives out a pictorial view. In other words, a pictorial display of the events and their corresponding probabilities. So this is just going to give you a highlight of what we are trying to achieve at the end of the day. Because something that has been given in a computation manner or in a mathematical approach doesn't give a visual expression, a good visual expression as to something that has been drawn. Because remember these decision trees, just like the way we did them in probabilities, it is the same way we are going to do them here. But here, our focus is going to be on we are going to incorporate all these items. We are going to incorporate the alternatives, the state of nature, and at the same time, we put the payoffs plus the probabilities. Everything is going to be incorporated at once, but it is going to be in a diagram form. In other words, diagrams, even for those who don't actually know mathematics, they will choose that to be the best, because it will be explaining more details. It will show where certain things began and where they are ending. So it will help even those without accounting background to understand some of these aspects. That's why we find that in most of the times they are asking the decision tree. I'm not saying the other one, they don't ask it, but most of the times, because if you try to look at the simulations that we have down here, you are seeing that there are very many trial numbers that we listed that were, most of the times they were requiring us to get the decision tree done. So we've said that a decision tree is a pictorial display of the event and their corresponding probabilities. It should be used where a problem involves a series of decisions being made and several outcomes arising during a given decision making or during a decision making process. In other words, the decision trees are drawn from, these decision trees, we always draw them from left to right, with boxes representing the decision points and circles representing the outcome points. That's just giving us how we be able to draw this. But because sometimes we will say that if we don't want maybe to compute like the way we have done in the first approach, just like we haven't computed it, but you will see how we do it under the expected value. Because in the expected value, it is more of a mathematical approach. But here, we are incorporating in a diagram that will help us understand. That's why we are using boxes to represent the decision points and circles to represent the outcomes. Because if you get those things and if you draw a box and you provide the key to someone who doesn't have the mathematical ideas, he can also follow those boxes, and he knows that when I say box, I'm seeing a decision point. When I see any circle, I'm seeing an outcome point. The person can be able to follow that and understand it very well than using the mathematical approach, because the other mathematical approach involves getting formulas. Though we may find ourselves incorporating some of those, but the other one, it will give a more visual impression to the reader. So we've said that sometimes the examiner tells tells us to draw a decision tree. And sometimes it just tells us to compute and advise on which project or which alternative they should undertake. But we should know how to be able to draw this decision tree, because a decision tree makes your information more understandable, just like what I have said. Because even the other information that we draw or that we solve using the mathematical approach, we can straight away put that information on a decision tree. So it is very important for us to understand how to draw a decision tree, because it serves two masters at once. So we said we are going to have what we call the boxes. And those boxes, they are going to be showing decision points. In other words, which decisions the decision maker wants to undertake. And we are also going to show the alternatives. We said those alternatives are also going to be, there may be alternatives that we are going to represent using those boxes. There may be decision points. A decision point may be in terms of the things you want to undertake. If you're starting a business, going to school, or doing anything, that may be our decision point. But these outcome points, we have to show what will be the result, or what we are expecting if at all we pick a certain alternative. So we shall look at how we can be able to incorporate the other example that we had. We have a simulation up there. We shall do that simulation, and we make sure we finalize it using the expected value. And at the end of the day, we also use that to draw a decision tree, so that we can be able to get the differences. I'm very sure with the differences, if we do the mathematical approach and we also convert that to a decision tree, it will help us understand more and more. So with that, we can't exceed there, because the next video is going to be on the simulations. We do those simulations, we'll be able to see the difference, and we can be able to understand what we can have. So thank you for watching. For those who haven't subscribed, please do, because it will help the channel to grow, and at the same time, it will help you get notifications, or you get notified whenever we upload more videos. As long as you subscribe to the channel, that's all that we need from you. Thank you for watching. Let's meet in the next video.